Calm it down. All right. All right, let's talk about this first proof. All right, so if we take a look here, it says given angle A is a right angle, angle B is a right angle, prove that angle A is congruent to angle B. So the first thing we always do with any proof, we start with step one, which is our given. So we could say angle A is a right angle, angle B is a right angle. And the reasoning for that will be it was given to us. Step two is where we talk about what kind of goes in the middle in order to prove that these two angles are congruent, but there's not much, right? Do we know angle A and angle B are already congruent? Yes or no? How? Because they're both right angles. So what you would just do here is you would put angle A is congruent to angle B, and you would just put all right angles are congruent. So this is an example of a two-step proof. Two steps is usually here's your given statement, and then you can just go right into proving it because there's something there in the given. All right, let's take a look at example 2. It says given JK is equal to 2.5 centimeters, so this is 2.5 centimeters, NO is also 2.5 centimeters, you need to prove that JK is congruent to NO. So again, just like before, we're going to start with those given statements. So JK equals 2.5, NO equals 2.5. So that's given. Now, they want us to prove that these two segments are congruent. Do we know that they are already congruent or not? Yeah, how? They're the same length. So if we put 2, we would just go straight into it. JK is congruent to NO. And all you have to put here is the definition of congruent segments. Now, the other thing I want you to notice here is you guys notice how this given, it doesn't have a line above it for the JK, but when we talk about the congruency, it does. Do you guys see that? Anytime you are talking, remember how if we're talking about the measure of an angle, we put a little M in front? Not having the line there is like the M, okay? That when you're not having the line above a segment, it's talking about a measure. When you're talking about just the segment itself in a theory, that's when the line is above it saying, hey, this is a segment. So we have to put the line up there to let them know it's a segment, okay? So whenever you're in congruency, you have to be very careful about the notation compared to when you're not, or when you're in equality, okay? All right, questions on that? All right, let's take a look at example 3. So this says, given, again, we're given this diagram, prove that APR is congruent to SPB. All right, so I'm first going to start with, I'm just going to put diagram as shown. And that's what's given to me. Now, step 2, we're trying to prove that APR, so this guy right here, is congruent with SPB, which is right here. So do we know that they're congruent? Yes or no? No, because we need to define them as something first. We're not told anything about this. However, because this is the diagram and because we see these straight lines, we can assume that we have two straight angles with those two, okay? So I'm going to put angle APR is a straight angle. And I'm also going to put angle SPB is a straight angle. And that is assumed from the diagram. Now, it would probably be really tempting to say APR and SPB are straight angles. Don't do that. Technically, these are two steps that you are combining into one because they have the same logic behind it, okay? You can combine these, but you have to individually write out, hey, SPB is a straight angle. Hey, APR is a straight angle, okay? Okay, now that they are both straight angles, we can take a look at part 3, all right? Since they're both straight angles, what can we now assume? What can we state without a doubt? Yeah. Their measures of them are equal, making them what? 180, which makes them congruent. So all we have to do is put angle APR is congruent to angle SPB. And we would just state that all straight angles are congruent. Yeah. We're talking about congruency, so no. We don't have any physical numbers here. So if we had if we said that the measures were equal to each other, even if we didn't know the number, that means we're putting an equal sign between them. Because congruency is a theory, we don't include the M because we're theorizing that they're equal. We don't have an actual this helps prove that they're equal, but we have to use congruent because we can't physically do each thing. Does that make sense? So we have to assume that they're that. Good question. Any other questions? All right, let's take a look at the next example. So there's a little bit of an error here that I want you guys just to fill in. Can someone identify the errors here? We just kind of talked about it. There's an error right here. Yeah. Put the M's. Yeah, put the M in front of the angle 1, angle 2, angle 3, and this guy. We're going to prove that it's equal to 90 degrees. All right, so there's supposed to be an M in front of there. There's the error. All right, so step 1, again, always work with those givens. Now, if you want to, you can also split up the givens. I have an example for that as well. Okay, so we're going to have measure of angle 1 equals 20. Measure of angle 2 equals 40. Measure of angle 3 equals 30. So that's what's given to us. Yeah. Yes. Without the given, you have nothing. Just sorry. Nature of the beast, right? All right, so for part 2, now, if we're trying to prove that this whole thing is 90, that means we're going to do what with angle 1, 2, and 3? Who can tell me? Go ahead. We have to add them together. But I can't just go straight into adding. I have to set it up first. So I have to state here that the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 equals the measure of angle X, Y, Z. Sorry, I kind of went over on the next side. And someone tell me why? What did I just do there? What property possibly? Yeah. We added up all the measurements. So what is that? Angle addition postulate. Very good. All right, so now for step 3, we added all this up. I'm going to take what's given to me and put it in. So this is 20 plus 40 plus 30 still equals that measure of x, y, z. What did I do here? Go ahead. Okay, so I use those measurements and I put them in. So what did I physically do with those measurements? Substitute. Yeah, it's a substitution property. All right, so we're on the substitution property. I would like to just stress real quick. Notice how I spelled out substitution. Don't put sub, because we have the subtraction property of equality. We also have substitution property of equality. We have all of these properties that actually begin with SUB, and I'm going to need to know the difference on a test. Does that make sense? So spell those out. See, this one, I know I can get away with add, just putting the word add here because there's an angle in front of it. Okay, but I would never put add property of equality. Put addition, like spell the actual thing out, okay? All right, so let's take a look at this. So now I did this, and now I know when I add these up, I'm going to get 90. So step 4 is going to be 90 equals the measure of angle X, Y, Z. Someone tell me, what is the reasoning behind that? Uh-oh, sorry. I didn't know it got on there. I'll rewrite it. Good. It's not the addition property of equality. Not the definition of complementary angles. I added up the numbers, yes. But it's not addition property of equality because I'm not adding to the other side. Not addition postulate. Super close. You're on the right track. You're not going to write down anything that has the word addition in it. What happens if you put everything on one side of an equation together? What's that called? Combining like terms. Yep. The only other one that would be acceptable here is simplify. However, you're probably going to see combined like terms more because you're going to have different terms on different sides. So, all right. Now that I've done this, now here's my question. I did technically prove, oops, sorry, I forgot the M didn't transfer. I did technically prove that this is 90, but what's the issue here? I mentioned that issue yesterday. What's the issue? I said proofwriting is very nitpicky. Does step 4 look like what I'm supposed to prove? No. What does it look like? Good.
Wait, how didn't you prove it?
It's backwards. It can't be like that. It has to go. The measure of angle XYZ equals 90, and we have 90 equals the measure of XYZ, right, Evan? Make sense? Okay. So what I'm going to do here is I'm going to have one more step. I'm trying to find something that'll work. Let's do purple. All right, so step 5 is going to be the measure of angle XYZ equals 90. Who can tell me the rule now? It's one of the new ones we learned. Well, not new, but ones that were kind of added into your worksheet yesterday. Which one does the flipperoo? Which one? It's not transitive. This is why I said, huh? Symmetric property. Very good.
Multiple choice? No.
Some of it is multiple choice, some of it's not. Once, I mean, here's the thing, guys. eventually, now again, this is my pro tip. People, all the students, even if you're not that strong at this at first, they kept going, they kept persevering, and they kept asking questions. They got really good by the end of the year to the point now that they're tutoring other students in it. My recommendation is this: persevere. Keep working on it. Don't quit. Okay? Yes. I'm sorry, time out. Say it one more time.
Is there like a list of all these names that these people are finding?
We've been working on these slowly since the beginning of the year. We've done the angle addition postulate, but it's been more of an example format. Now we're applying it in a proof format. And remember I did say take off the notes from yesterday, symmetric properties on there. Yeah.
Like all of the,
Yeah, can you make us a list so we can study?
Yeah.
I would recommend you make your own.
How do we discover them? What if we don't know all of them?
It's all in your vocabulary sheet. It's all in your notes. I promise you. It's all there.
All
All of them.
all
All of them.
I don't think so.
One of the vocabulary sheet from yesterday has all that in it. It doesn't have all of these. What I'm saying, it has all of some of the stuff we did, like that symmetric properties in there.
How do you use all and some in the same sentence?
Because the rest of your notes contain the rest.
Oh yeah.
We didn't get rid of the ones.
All right, let's move on. All right, number 5. Is anybody still writing? Because I am going to erase. All right. Number 5, it says given WS bisects RWP. So here's RWP, here's WS. I know that this is going to be congruent with that, so I'm going to kind of muck it up a little bit. It's okay to draw on these. They want us to prove that RWS is congruent to PWS. So again, I'm going to start with that given. Ray WS bisects angle RWP. That is what is given to me. So if that bisects, what do I know about those two angles? They're congruent, so you can just go straight into it. Angle RWS is congruent to angle PWS. And that's because of what? Very good. Definition of an angle bisector. That's it. Proven.
No, wait, are you mixing up the letters there? It was RWP and now it's RWS.
No.
The main one and then
Yeah, RWP is this big one right here. They give that to me. So I didn't mix anything up.
Oh, okay. I see.
Okay. Good question. I'm glad you're asking. Are there any other questions?
What is the top word?
The top one is just repeating this right here. Same thing.
I don't know. What is the number 2 word say?
Oh, definition of angle bisector. That's an angle symbol. Here.
Exactly down the middle. No?
There you go. What?
Is the bisector always roughly down the middle?
A bisector always splits it in half, yeah.
So no matter what, it's gonna be the same number. So they're gonna be
In
congruent.
theory, yes, it should be the same number. Because we don't have that physical number, that's why we use congruency. All right. Any other questions on 5? All right, let's take a look at 6. All right, so step 1, they're saying given B is the midpoint of AC. So here's AC, which means this is congruent with this, right? So here we're going to have B is the midpoint of AC, and that is what is given to me. Now they want us to prove that AB is congruent to BC. Can I just jump into it, or do I have to have something else?
I have a question.
Yeah.
How do you know how many steps are in each one?
You don't.
Oh, even harder.
Because that's why I keep saying, do I have enough information here to physically prove this, or do I need something else in there? So do I have enough here? I do. So that's why this one was 2 steps and the one above it was not. I didn't have enough information in the last one. All right, so in this case, I'm going to state that AB is congruent to BC. That is by what? Who can tell me? Yes. Definition of a midpoint. Very good.
Yo, they got here, so let's probably
Questions on this? All right, let's take a look at number 7. All right, this one states, given angle 4 is complementary to angle 6. And then I also have angle 5 is complementary to angle 6. That is what is given to me. They want us to prove that 4 and 5 are congruent, like that's the goal. But I have this little middle one that says, hey, okay, this is complementary to this is complementary to this. Do I have enough information to prove that those two are congruent? Yeah, by what? Go ahead. Yeah, but what's the rule? Not transitive. It's on the sheet from yesterday. Congruent complements theorem. Nice job.
They believe in us.
God, dude.
Bro, wait, what was the answer? Well, that means they're all congruent. Bro, what?
Okay, here, just as a recap, here's what the congruence complements theorem is about. You have one angle that is complementary to this angle, but then you also have this other angle that is complementary to this. So that means if both of these have this angle as part of the complementary process, then these two have to be congruent because it's like subtracting this out. Okay? Questions on that? All right, let's take a look at number 8. All right. So we are given that the measure of angle 1 is 37 degrees. So I'm going to write that in. Measure angle 1 equals 37 degrees. We're also given that PTR, so the entire angle, is 53 degrees. So measure of angle PTR is equal to 53. That is what is given to us. Yes, Ireland. Okay, so the thing we need to ask ourselves now, they want us to prove that the measure of angle 2 is 16 degrees. We have to set this up. What's the setup going to be? This is a lot like, what was it, example 5, I think it was. Go ahead.
Measure of angle PTR minus the measure of angle 1.
Close, but no, we don't have a subtraction angle property. We have to use what instead?
So
Yeah. Yeah, measure of angle 1 plus a measure of angle 2 equals the measure of PTR. That's what we're trying to prove. Yeah, but you gotta set up. Here's the thing, guys. You are 100% correct. We're subtracting it. Everyone in this room saw it right away. Here's the issue. We do not have subtraction, an angle subtraction property. We only have the angle addition property. So we have to set it up as an equation using that property, and then we can subtract. Okay? So I'm setting this up as the measure of angle 1 plus the measure of angle 2 equals the measure of angle PTR. And I did that by the angle addition postulate. Now, step 3 is for me to take the given information and put it into that equation. What am I doing there? Go ahead. It's not angle addition again. It's well, hold on, not yet. That'll come at the end, Ireland.
Substitution property?
Substitution property. So angle 37 plus the measure of angle 2 equals 53. That's substitution property.
Okay, well, wait, we already did.
Now, I'm going to subtract that 37 from each side, leaving me with the measure of angle 2 equals 16. What property did I just apply there? Subtraction property of equality.
Wait, is that the thing that was like combined with
And now, does that measure of angle 2 equal 16 look like what we were supposed to prove? Yes, so no symmetric properties required, we're good. If it's flipped at any point, use that symmetric property to bring it back around. Yeah, Evan.
Why can't we just say like 37 plus 16 equals 53?
You can't.
It's not a theorem.
Because you have to prove that it is. You can't just go for it. Okay, time out. Here's my question for you guys. We have equality, we have congruency. Do you think you're going to constantly be given numbers? No. And do you think you're going to have to apply this process even if you don't have numbers? Absolutely. That's why I had to do it this way. You're right. It's common sense, 100%. But if you don't have the steps to back it up, you are going to be in a heap of trouble. Does that make sense? Okay. All right, let's talk about this last one, number 9.
Yeah, we are not missing it. See? Now, this is more reasonable. They give you a step. And this is more reasonable of you.
Is it now?
Honestly, she should just fill it out for us.
No. This is the fill in the blank. All right, now pay attention, please.
Whoa. 5 and 6 are the same.
Okay, hold on. Pause. One thing at a time.
Oh, wait, no, they're not.
All right, it says angle 1 and angle 2 are a linear pair. BD bisects CBE. Prove angle 1 is supplementary to angle 3. Now, if we take a look at this, what they did here was they split the given. That is a tactic you can use where you take one piece of the given, kind of exhaust all the options, and then start working on that second piece. Okay? So that's why I'm giving this to you guys, because I want you guys to understand that there's multiple ways of doing this. So if we look at first that BD bisects CBE, that's given to us. We're seeing that angle 2 is congruent to angle 3. What's the property here? It's definition of, not midpoint, angle bisector.
Oh, it is bisector.
Because it says it's a bisector. It has to be. So, because these two angles are congruent, we can state that their measures are equal by the definition of congruent angles. And that definition works flip-flop too, that we already saw. We had the two angle measures equal, and we stated they were congruent. So that can go kind of vice versa. Now we have angle 1 and angle 2 are a linear pair. Well, What's that? It is not. What? It's given to us. It's right here. So that's our second given. So they split the given in this case.
She said she split it. So
Yeah.
yeah.
Smart.
Okay. So now that we know that they're a linear pair, we have the measure of angle 1 plus measure of 2 equals 180. And what is it? You said it. You said it. Linear pair theorem. Very good. Okay, so now for this next part, we have the measure of angle 1 plus the measure of angle 3 equals 180. What happened? What? They switched 2 with 3. What is that? Substitution property.
I got something right.
How do I not know that?
And now that we know that the measure of angle 1 plus the measure of angle 3 is equal to 180 degrees, what can we conclude? They're supplementary. So angle 1 is supplementary to angle 3. What's my reasoning? Perfect. Definition of supplementary angles. You got your pencil. Supplementary. Because it is a proven statement, yes, you have to write out the whole thing.
So like whenever we're actually doing proof writing, is this how it's gonna be formed? Or do we like write a paragraph?
Okay, we're not doing paragraph proofs just yet.
Wait, there's paragraphs involved? Later. Yo, this is not English class.
All right, time out.
There's evidence tells you to prove a triangle has 3 sides.
Here's the thing, guys. When you're physically proving something, yes, it's usually 2 column like this. Okay. We are going to get into something very shortly called paragraph proofs in 1/8, but that's only to help you with the indirect proofs. If you do a 2 column with an indirect, it's going to be very messy. So it's much easier to do as a paragraph. Okay. And believe it or not, proving stuff like this is easier to do 2 column than in a paragraph.
Can you possibly prove that a triangle has 3 sides?
3 sides?
Yeah, that's all you're getting. So please answer the question.
Okay, so if I'm given a triangle, and if I analyze the word triangle,
Oh, wow.
tri means 3. Therefore, this has 3 sides.
What reasoning or what theorem or definition are you using?
I'm using Greek for tri.
Yeah, that is way easier than what I've ever heard you.
All right, so, all right, listen up. Here's what I want you guys to do. Take out your laptops. I'm going to assign you 2 Google Forms that kind of redo like the P's and Q's. And I'm going to assign you that Scoot activity. Whatever you don't finish in class, finish at home. Those who watch at home, have a great day.